Imagine you're trying to find the perfect apartment, the perfect parking spot, or maybe even your future spouse. You have 100 options in front of you, but you can only evaluate them one at a time. If you reject one, it's gone forever. Pick too early, and you might miss the best one. Pick too late, and all the good ones are taken. But what if I told you there is a mathematical cheat code that guarantees you the absolute highest probability of making the perfect choice? It's called the 37% rule, and here's how it works. Let's make this precise. It's known in mathematics as the secretary problem. You're hiring a secretary from n applicants. They arrive one at a time in random order. After each interview, you must immediately accept or reject. No callbacks, no going back. And your goal isn't just to find someone good. You want the absolute best candidate. The catch? You don't know the scores in advance. Your first instinct might be, just pick one at random. But with 100 candidates, that gives you a measly 1% chance. What about always picking the first candidate that seems impressive? The problem is, you don't know what impressive means yet. Always pick the last one? Still 1%. All these naive strategies give you roughly the same terrible odds. Surely we can do better. Here's the beautiful insight that changes everything. Split your search into 2 phases. Phase 1. Explore. Look at the first R candidates, but reject them all. You're learning what good looks like. Phase 2. Exploit. Now you're armed with a benchmark. Accept the very first candidate who is better than everyone you saw in Phase 1. The million-dollar question is, what is the optimal value of R? Let's work out the math. We win if the best candidate is in the exploit phase, and the best of the previous candidates was in the explore phase. Summing over all possible positions of the best candidate gives us this elegant, discrete sum. As n approaches infinity, this sum converges to a definite integral. Negative x times the natural log of x. Taking the derivative and setting it to 0 gives us exactly 1 over e. That's approximately 37%. Let's build some intuition for why 37% is the magic number. Slide it too far left, and you're picking almost blindly. Slide it too far right, and you've rejected nearly everyone. But right here, at 37%, that's the sweet spot. The optimal balance between learning and deciding. Now let's watch the algorithm in action with 20 candidates. Our threshold R equals 7. We interview the first 7 and reject them all, keeping track of the highest score we see. Now we enter the exploit phase. Each new candidate gets compared against our benchmark. The moment we find someone who exceeds it, we hire them on the spot. Let's see the full picture. This curve shows your probability of selecting the best candidate as a function of the threshold. The peak sits at exactly 1 over e, giving you a 36.8% chance. Compare that with the random strategy's 1%. That's a 37 times improvement. Don't just take the math's word for it. Let's run thousands of simulations. For each possible threshold, we simulate the algorithm 2,000 times. Watch the empirical results land right on top of the theoretical curve. Theory and experiment in beautiful agreement. And here's the truly remarkable part. This works for any number of candidates. 5, 10, 100, 1,000. The optimal fraction is always 1 over e, and the success probability always converges to about 36.8%. The 37% rule isn't just a mathematical curiosity. It applies whenever you face an irreversible, sequential choice. Apartment hunting, dating, parking spot searches, hiring decisions. The recipe is beautifully simple. Explore the first 37% and reject them all. Set your benchmark, then pick the first option that beats your reward, a 37% probability of making the optimal choice. Next time you face an impossible decision, remember, sometimes the best strategy is to deliberately reject what looks good, so you can recognize what's truly great. If you have enjoyed this mathematical journey, be sure to subscribe and see you in the next video.